Again, something I never actually found before, and I'm going to bring this up a lot larger shortly, is the human error rate table. This actually comes from a reliability engineering book that's been around for a few years now, and it is the average of human error rate across industry across the world. It's a number that represents a typical situation. Now, every company is different, every person is different, every situation is different, so that number will be different depending upon the circumstances, but it's indicative. So I want to stick with this as an indicative representation of what it means in terms of human error rate and the effect on human error. And of course, the whole point of this is to find some answers, to minimise human error, because we saw before that human error leads to 10 to 100 times greater failure rate than had there been no human error. So let me bring this up so I can read it together with you. Okay. Just have a read of what this table says. So we have here human error rates of in the order of 1 in 10,000. So for example, read a 5-letter word with good resolution wrongly, 3 in 10,000. Let me just explain that so that we get the numbering right. So 0.0003 is the same as saying 3 over 10,000. So in 10,000 times of reading a 5-letter word with good resolution wrongly, 3 times we'll read that word, think it's something else, but think it's still right. We'll misread and think it's right, 3 in 10,000. Not very often, but it happens. Another one here, select wrong switch, the mimic diagram. So I've got a diagram of the switch panel. I'll get that wrong 5 in 10,000. Not very often, but that switch is one that leads to a failure. Then every now and again I'm going to throw the wrong switch and it'll lead to a breakdown. Fail to notice crossroads. Fail to notice major crossroads, 5 in 10,000. There's a story of a truck driver in Australia who was driving between 2 country towns. They were doing a construction in one of the country towns and taking the dirt on this tip truck to another country town to get rid of that dirt. And between the 2 country towns there was a railway. And for many, many months this truck driver would go from the construction site to another country town, dozens of times a day. And every time he'd go across the railway, no train, no train, no train. Day after day, week after week, month after month. One day there was a train. He hit it. 5 people died. And what happened was he didn't see it. Because for hundreds of times on that section of road up here in his brain, no train. So in his brain had said, well, this section of road, there's never a train. There's not going to be no train today. Unfortunately, there was a train today. And this is how we get it wrong. Yeah? Things that we see repetitively are not a problem. If there's a change, our brain doesn't see the change. It just accepts it was like it was the last 10,000 times or 110 times, and in this case, 5 people dead. Now I'm noticing as I'm getting older, this is happening more to me. I'm actually going to fridge doors to put my shoes away in a cupboard. I'm thinking, hey Mike, what's happening here? It's because up in my brain, I have got a groove. My brain has created an arrangement of neurons and signals that when I go to this white door, it is a cupboard. It happens to be a fridge white door, and I open up the fridge to put my shoes in. And then of course it twigs. This is how we're designed. Our brain's designed to simplify things down to the bare basic processes and then make it a habit. You know, I'll drive home and I can drive and then not even think about how I got home. I went through all the lights, I turned left, right, here, there and there. How did I get home? Up here, our brain has got a set of arranged neurons and it just follows that rule. And this is what happens with older people. Anyone older than 50, you've got to watch out that which groove are they on today. If they're in the wrong groove, they'll just go automatically, not even think about it. And that's human nature. Has been, always will be. And we're going to be smart enough to realise that. So maybe for old guys that are 50, maybe I better give them a buddy. You know, me, 56, I better get Fred here. Fred, he's 35. Fred, just check on me every now and again, make sure I haven't made a mistake. And I do that on purpose. I buddy Fred up with me because of this situation here. The way we are designed as animals and human beings, our brain works that way and we can never change it. So every now and again we'll get caught out. Now that was simplest possible task. Then we go down to routine simple task. So read a checklist or digital display wrongly, 1 in 1,000. So we've gone from 1 in 10,000 range to 1 in 1,000 range. Another one down here, wrongly carry out visual inspection for a defined criterion. So go and look for a leak on this valve or this machine, whatever the case is. Though I'm told exactly what to do, I will get it wrong on average 3 in 1,000 times. Failed to correctly replace PCB. My instrumentation tech or my electrician pulls a motherboard out of a PLC program, a machine, puts a new motherboard in, and he thinks he's got it in right, but in fact, 4 in 1,000 times it's actually wrong. And that's just the nature of the beast. We do a job, we think it's right, in fact, we have not gone the next step to confirm it is right. Then across to the other side of the page, we are into a routine task with care needed. For example, mate a connector wrongly. I've got 2 hose fittings, I've got to put them together, and they'll be done wrongly 1 in 100 times. So we're getting to the situation now where it's happening more often, and some of these things are getting tricky to do as well. What's another one there? Do simple arithmetic wrongly 1 in 100 to 3 in 100 times. So if your technician has got some mathematics to do in his instructions, in his work task, and he does the mathematics wrongly, then if I have 100 technicians, then I can guarantee one guy at least will have got that particular calculation wrong. Now, if the calculation is wrong and he puts that number into his program or into his calibrations, then that's now going to go wrong as well, all because of this particular risk of mathematics being done incorrectly. Interesting one down here. Read 5-letter word with poor resolution wrongly, 3 in 100. So as things get hard for our brain to pick up on, we start making more mistakes. It begs the question, for example, if here we have read 5-letter word with poor resolution wrongly, it's 3 in 100. 3 in 100. And back here, we saw read 5-letter word with good resolution wrongly, 3 in 10,000. And the only difference is resolution. What should I do with my procedures? How should I present information to my guys? Because if they can't read it very well, lots of mistakes. If I can make it clear, easy, obvious, colour, bolding, lots of white space, I then create a situation where the error rate goes right down. And this is a choice that maintenance planners have to make. When maintenance planners put together their procedures, their documentation, what's the smallest sized font you should have in documentation going to operators and maintainers? Because if they can't read it, they're going to start making mistakes. So what I say to my guys in my maintenance planning course, I ask the question, what's the smallest resolution you should have on your documents? Because I can actually create high reliability by having information easy to read. Normally settle about 12-point font. Nothing smaller than a 12-point font in documentation going to maintainers. I'd be happy with a 14-point font because it says so here. If the guys can read things clearly and it's easily to resolve with their eyes, they will make less mistakes than if they can't resolve it. Their brain will make up the words. And there's 100 times less failure in having good documentation. Easy to read. Our brain loves colour. Colours, imagery. So less and less words, more and more pictures. Clear pictures, and the picture becomes something our brain latches on very, very quickly. We love visual information. So this table here has some very interesting outcomes for us to use. Another one here. Put 10 digits into a calculator wrongly, 5 in 100 times. How many guys have misdialed the phone number? You've all dialed the wrong numbers over the years? Happens all the time. It's just the nature of being human beings. Now we get into the situation of maintainers. Now we're into the complicated non-routine task area. And here the failure rates are typically 1 in 10. So when things get complicated and non-routine, as maintaining machinery is, our machines are very involved engineering devices, and we don't do this sort of work all the time, day in, day out. Now we're down to a situation where we have a real serious risk. Fail to recognise incorrect status in a roving inspection, 1 times in 10. So if I have a work order and it is to go and inspect the plant for problems, I'm going to walk past one problem in 10 because my brain doesn't pick it up, and that's just the nature of the beast. If I add stress on top of that, as in environmental stress or stress from unrealistic expectations, I go up to 0.25. So the guys that tell you they work best under stress, so I love stress, I work the best, balderdash, not true. Because stress makes our brain blinker. We're going to escape the animal chasing us, the beast behind us in the jungle that was chasing us through the trees. That's stress. And our brain blinkers right down to escape one pathway, not multiple pathways. The one that really scared me when I first saw it was the very last one. Failed to act correctly after 1 minute in an emergency situation, 9 times out of 10. 2 minutes into this emergency situation, everything goes wrong. So in maintenance, we don't want to have our guys in emergency situations. Because in an emergency situation, we do not think straight. We are not built to think straight in high risk situations. So maintenance, if it comes a high risk, high stress scenario where things are done in emergency environments, then things are going to go wrong automatically because we just don't see all the options available to us. To me, this table actually is interesting because it gives us an answer of what we need to do. It says over here, where the sigma rate is a failure rate of 1 in 10, which is a sigma rate of 2 to 3 sigma. If we go from complicated non-routine task to routine task with care needed, to routine simple task to simplest possible task, we go from 1 in 10 to 1 in 100, 1 in 1,000, 1 in 10,000. Make things simple. Keep things very, very clear, very, very obvious. And the table tells you what's going to happen. You're going to get less troubles. Now these numbers here, just going to show you a couple of things more about what the table's actually telling us. This number 2, fail to recognise incorrect status on a roving inspection. So if I have a work order that's a roving inspection, I have an error rate here in the range of, what is that, 1 in 10. But we saw before, if I then go in and convert my work order to a defined criterion, so wrongly carried out a visual inspection for a defined criterion, it now becomes 3 in 1,000. So I've gone from 1 in 10 chance of error to 3 in 1,000 chance of error simply by introducing defined criterion. Go and inspect for this, and inspect for that, and inspect for this one, inspect for that one. Very clearly. So I now develop a checklist, as it says up here. Read checklist, digital display wrongly 1 in 1,000 times. If I define exactly what to look for, then I am creating a high reliability situation. So my documentation now is valuable to me. If I create a process where I have defined criteria, look for these things. If it's not there, then report. If it is there, great, carry on. The table says to me, I will produce reliability. I'll produce a far better outcome and far fewer human error effects. So this table is very valuable. I wish I had a bigger one. I've been looking for a more and more table with more of this information because it's telling us what to do. From 1 in 10 to 3 in 100, to 3 in 1,000. Just by writing good documentation that's easy to read with defined things to look for. Now, of course, that means my documents are going to be thicker. Of course. I'm asking guys I'm going to be writing with bigger text, more pictures, and asking them to look for specifically these 25 things. So I'm going to have more documentation. Is it worth it? Is 1,000 times less mistakes or 100 times less mistakes worth it? Your risk matrix will soon make it clear if it's going to be worth it or not. Now, another thing too that's changing technologically wise is paper will be replaced shortly with things like iPads and things like handheld computers. So when I've got that technology, then it doesn't matter how long the paper is because it's going to be electronic and I can have immediate feedback to my PLC, wireless connection. So technology is going to take all this into a tool that will very quickly let us interact with our database and feed our raw data from the inspection directly back into our analysis packages and tell people within 30 seconds that, hey, this is not what the things are changing. Something's out of place or something's having a problem in its operation. So as a manager, if I'm not aware of the impact of human error on my operation, I would never go and look at using those sort of tools. I would never think about, hey, you mean a piece of paper will create this situation for me with a decent documentation and some simple checklists? Yeah. You start using checklists with defined criteria, you will create that situation. And nothing else has to change. But of course somebody has to write that. Somebody that knows the machine, knows what they're looking for, knows what the problems are, will have to write that documentation. That might mean an engineer for a couple of days. Is it worth it? Is it worth paying an engineer for 2 days to write good documentation my guys can then apply and minimise human error? I think it is. But each company has to make that choice for themselves. But there's an answer. The answer's there, has been there. Well, this goes back to the 1950s, 1960s. That table is that old. Been around for 50 years. So yes, we have an answer in that table. We have what to do is to simplify things, to make things clear for our brains, to give our brains information to work with. Pass, fail, yes, no. Very clear, defined criteria. And you will create